Hello, my name is Ryan Valera. This is Project 5, Digital Processing for Physics 120. I will be showing the circuit that I built for this project to begin with. First off, we have our Raspberry Pi that is plugged into our computer as per usual. And we have 3 wires, which is all we will need for this circuit. We will need the red wire, which corresponds to a voltage that we will be using to power our microphone there. We have our ADC input that we will be using to record the data that the microphone is outputting. And then we have our ground, which is our black wire. It's a little hard to see, and I apologize for that, but hopefully you can kind of see it. The blue wire is on the far left, the ground is in the middle, the red wire is on the far right, which corresponds exactly to what the microphone wants. Our output signal is going to the blue and going back into the Pico over here in our ADC0. Our ground is to the ground and our voltage is to the voltage. We also have a 1 microfarad capacitor to try and get rid of some of the excess noise that our microphone will be picking up when we are doing any experiments for this project. The next thing that I will be showing you for this project is to show that this is actually working and receiving some data. I will be showing an 800 hertz sine wave with an amplitude of about 1 volt or so. I apologize also if this is going to be a little bit loud. I can't really do much about that. My code is already running and printing what it is that it needs to be printing. And this is before we start any sine wave of any sort. And this is what we see. Sort of sinusoidal in nature, but not exactly the greatest. But when I use our tone generator, what we will end up seeing is a good sine wave, hopefully. So I am going to go back to my code, and then I will just be showing just apply. And the reason why it's not exactly 1,000 volts right now is because it's kind of small, or the volume is low. I can turn up the volume a little bit and hopefully fix that. And as you can see, it's pretty close to being 1,000 volts. So just messing with the audio is enough. So now that that is done, I'm going to turn this off. Okay. The next thing that we will be doing is to try and find the regular noise level that our room will be at before we are playing any sort of tone of any kind using the fast Fourier transformation. So I'm going to have to block out some of my code. So give me one moment while I do that. So this is the part of it that will measure the fast Fourier transformation and print out the noise level right here. And I am going to need to print out or comment out this so we don't see a bunch of extra stuff. So when I save it, this should just give us the regular noise level of the room ambiently in millivolts squared. So the next part that I'm going to be doing is you're supposed to take just kind of eyeballing that noise level measurement, and you're supposed to create a constant for it, which I did up here. And I gathered it's around like 14,500 millivolts squared, or at least that's what it was when I was looking at it and created the constant. So the final thing that you ask us to do is correctly identify the noise level of 4 different measurements. The next thing that I will be doing is showing the measurements of the 4 different things that we need to be doing. 400 hertz, 800 hertz, 1600 hertz, 1300 hertz, or 3200 hertz. The first thing that I'm going to be doing is messing with the tone generator and trying to get the volume to be high enough to get a proper measurement. This should hopefully be loud enough. And then I'm going to edit our code so that it is no longer printing out the ambient noise level. What I'm going to be doing now is what was instructed of us and just printing out the largest significant power in a varying or an amount of inputs. So when I resave the code, it should be printing out new things now. So if I did everything right, what this should do is when I play a certain frequency, this should be outputting that certain frequency if I did my code right. So we're expecting around 400 hertz, so I'm gonna play it. And now, if I did this right, it's around 400 hertz, which is what we wanted. We wanted it to also be for 800 hertz. So let me change that a little bit. And now, it is pretty close to 800 hertz. If I messed with the volume a bit more, I could get it closer. But it's pretty close. We also wanted 1600. Okay. It's pretty close to 1600. I can make it better if I mess with the volume a bit more. Now finally, we wanted 32. And again, it's pretty close. Or at least it was. Well, there you go. It's pretty close. I can get it closer, but I don't want to keep listening to this freaking super loud sound. And that is my project.